Hello, baby, Yadamari. Hi. Uh, so we are waiting for very long, but I don't think anyone is going to join us. Anyway, so let's start the session. Um, so this is week 11, assignment 11. So we will be solving previous year's assignment 11. There will be total of 10 questions, and let's start. All right. Okay. So yeah. Week 11, assignment 11, question number 1. So, this, yeah,
Screen is not visible, madam.
okay. Is it visible now?
Yes, madam.
Ha, okay, let's go. Okay, so the first question here is the wave impedance at a frequency equal to twice the cutoff frequency in a waveguide of TM mode is. Okay, so the first question here is wave impedance is asked, okay, uh, for TM mode in a waveguide. Okay, so what is asked here? Wave impedance is asked, all right. Wave impedance is asked to us at a frequency equal to twice the cutoff frequency. The frequency is given to us. Frequency here is 2 of Fc. Alright, 2 of Fc for a TM mode. Okay, so for TM mode, we know that wave impedance, the formula for wave impedance will be, okay, so here it's given that F is equals to 2Fc. So for TM mode, the wave impedance will be equals to eta, that is free space impedance, into under root of 1 minus Fc by F. Here Fc is cutoff frequency, F is the wave frequency in the waveguide square. So the whole formula here is eta into, so so we have started, and I was solving question number 1. Okay, so question number 1 here is a pretty simple question. Here it's asked that what will be the wave impedance for a frequency equals to twice the cutoff frequency in a TM mode. All right, this is what is asked in the question. So for TM mode, we know that the wave impedance is equals to, this is the formula, eta into under root of 1 minus Fc by F square. Okay, so here we know Fc, which will be, we know the ratio of Fc by F, that is 1 by 2. Okay, alright. So we know the formula for the wave impedance, which is equals to eta into under root of 1 minus Fc by F square. This is for TM mode. Okay, we will put all the values, we will get 0.866 eta. Okay, so option B. Option B. Alright, is there any doubt you have? Okay, everyone is.
Madam, sorry, madam. Once you open the formula, I will write, madam. Lately joined that
Okay,
wave impedance formula.
okay, no issue. I will explain again. No problem. I will explain again. So the question
Sorry,
is,
madam. Lately joined today.
it's okay. It's okay. No problem. It's okay. I will explain again. No problem. Since everyone else also joined late only. So yeah. So the first question here is the wave impedance at a frequency equals to twice the cutoff frequency in a waveguide for TM mode is. Okay, so what is asked to us? wave impedance is asked. Okay, what does wave impedance means? Can someone from you tell me what wave impedance means?
Madam, free space impedance I know that
Huh.
neta which is 377 ohm, but wave
Mhm.
impedance
Wave impedance is the impedance faced by the wave, electromagnetic wave in a waveguide. So in a waveguide,
we have to
yeah. See, when the
we have
electromagnetic,
to
huh, go ahead.
uh, madam, wave impedance means we have to match waveguide for input and output impedance.
We have to match it. Basically, what it means is the what will be the impedance faced by the electromagnetic wave in the waveguide. Okay, so for the waveguide, it is in the question. It's given that frequency is equals to twice the cutoff frequency. So this is given to us. Okay, and another thing which is given to us is it is working in a TM mode. The waveguide is working in a TM mode. Okay, so for this question, for TM mode, the wave impedance will be equals to eta into under root of 1 minus fc upon f squared. Alright, and since we know the ratio of fc by f, which is equals to 1 by 2, right? We know this. So it will become eta into under root of 1 minus 1 by 2 square, which will be eta under root of 1 minus 1 by 4. This will be eta under root of 3 by 4, right? And ultimately it will be equals to 0.866 eta. Okay, so this will be the answer, option number B. So here we will correct option number B. Is there any doubt you have?
No, madam, clear, madam.
Okay, okay. Let's go ahead then. Question number 2. So question number 2 here is the guide wavelength. Again, it's asked the guide wavelength at the frequency equals to 1/2 of the cutoff frequency. So here the frequency is equals to 1/2 of the cutoff frequency. So this is
1 by
given to
2
us.
FC.
1 by 2 FC. Yeah. In the waveguide for TM mode. Again, the mode is TM given to us. So now guide wavelength is asked. Can someone from you tell me how to solve this question?
Madam, guide wavelength means I know lambda g only I know, but
Yes.
lambda g no, madam. We need to find out lambda g.
Yeah. Okay. Okay. So
But
guide wavelength is asked to us. Okay. So see here at f is equals to fc by 2, that is less than cutoff frequency. If the frequency is half of cutoff frequency, which means that it is less than cutoff frequency, right? So the uh, if the frequency is less than the cutoff frequency, then the waveguide modes are evanescent. Okay, and guide wavelength has no significance. Okay, now so what does evanescent means? Can someone from you tell me what does evanescent mean? So evanescent means that it it cannot propagate in the waveguide. All right. Okay, so if a electromagnetic wave is sent into this waveguide, okay, with a frequency which is less than the cutoff frequency, then it means that the wave into the waveguide won't be able to propagate. It won't be able to travel, and thus there won't be any guide wavelength. There won't be any significance of guide wavelength. Okay, so here the answer will be not significant. Do you have any doubt? And you guys have any doubt? So here you have, what is the concept here? The concept here is, for those electromagnetic waves which are less than the cutoff frequency, those uh, waves, electromagnetic waves, won't be able to propagate, and thus there won't be any significance of guide wavelength. Guide wavelength here means that, see, in the waveguide there will be electromagnetic wave propagating, right? So whatever will be the wavelength of the electromagnetic wave propagating in the waveguide is guide wavelength. Okay, गाइड वेवलेंथ का मतलब यही हुआ कि वेवलेंथ सिंपल इलेक्ट्रोमैग्नेटिक वेव का जो प्रोपोगेट करिए गाइड वेव गाइड में, उसका वेवलेंथ क्या है, वही मीनिंग हुआ गाइड वेवलेंथ का. ठीक है, ओके, लेट्स गो अहेड. लेट्स ट्राई टू सॉल्व क्वेश्चन नंबर 3 हियर. Question number 3. A TE10 wave at 10 gigahertz propagates in a brass. Sigma c is equals to 1.57 into 10 to the power 7 Siemens per meter, rectangular waveguide with inner dimension A is equals to 1.5 centimeter and B is equals to 0.6 centimeter, which is filled with polyethylene. Epsilon r is equals to 2.25, mu r is equals to 1, loss tangent is equals to 4 into 10 to the power minus 4. Using the information to solve question 3 to 5, the phase velocity is, okay. So now let's try to understand the question. Here phase velocity is asked to us. Okay, TE10 wave is given, frequency is given to us, right? Conductivity is given to us, which is 1.57 into 10 to the power 7. It is given that rectangular waveguide is the structure of the waveguide. Now inner dimensions are given. Note that A is equals to 1.5 centimeter and B is equals to 0.6 centimeter. This means that A is bigger than B, right? So using the now, okay, these are okay, loss tangent is given to us. Let's see how to solve this question. Can someone from you tell me how to solve this question? Oh, okay, let's go ahead. Okay, so first thing that we have to find out is the cutoff frequency for TE10 mode, right? So here for cutoff frequency will be mu by 2a, है ना? Mu by 2a. So since the cutoff frequency, since here mu will be speed of light, right? For free space cutoff frequency we are asking, so here mu by 2a. So mu by 2a will be 3 into 10 to the power 8 upon 2 into 10 to 2 into 1 point this a. Okay, one second, this a, right? And mu here is given by c upon under root of epsilon r. Okay, right? I will directly make it like this. So 3 into 10 to the power 8 upon under root epsilon, or for TE10 mode it's given, right? So the frequency, cutoff frequency formula is this, mu by 2a. We will put it, we got this. Now for the phase velocity, one second, mu p, the formula for mu p will be mu upon under root 1 minus fc by f. Okay, so fc is given to us, fc now is given to us F is given to us. F here is 10 gigahertz, right? We'll put FC, we will put F. Now we know the mu. Mu is again C upon under root epsilon r. We know that. We know this. Will we be able to find out phase velocity? Hello. Hello.
Ah,
Ha.
madam.
Yes, ma'am.
Hello.
Ha.
Audible, madam.
Okay. Okay. Can someone from you tell me what is phase velocity? Go ahead. Try. Okay. Phase velocity is a rate at which the wave propagates in any medium. So there is normal velocity, right? Velocity of a wave, right? So when this wave travels in a medium, then this velocity changes, and the this velocity now traveling in a medium, this wave traveling in a medium will have a velocity, right? Now this velocity is known as phase velocity. Okay, so got it right. Now can someone tell me what is group velocity? Try. Okay, so for uh, you got what phase velocity is, है ना? phase velocity समझ में आया ना? जो वेव एक वेव एक कोई मीडियम में प्रोपोगेट कर रही है, तो उसकी वेलोसिटी को वी विल बी कॉलिंग इट एज phase velocity. Now group velocity is a velocity for a packet of waves in which the waves uh, uh, vary. Okay, so there will be uh, a group of waves, okay, uh, which will have a bandwidth of wavelength. Different wavelength will be there, different for different frequencies. So the phase velocity is the velocity for a single wavelength wave, all right, and group velocity is defined as the velocity for a packet of waves in which the waves vary. Okay, सो समझ में आया? एक वेव ट्रैवल करती है, एक वेव के मीडियम में प्रोपोगेट करती है, उसका वेलोसिटी को हम फेज वेलोसिटी बोलेंगे. जब हम ग्रुप ऑफ वेव्स को कंबाइन करके उनका उसकी वेलोसिटी निकालेंगे तो उसको हम ग्रुप वेलोसिटी बोलेंगे. ठीक है? ओके, एंड दिस इज द फॉर्मूला that we will be using, okay, for TE10 mode to solve this question. Okay, now let's go ahead. So the question number 4. Question number 4 here is, what will be the wave impedance? Again, I have already taught you what wave impedance means, right? So here, what will be the wave impedance? Try to solve this question.
Meter
Hmm.
root of 1 minus FC by F whole
Yes.
square, madam.
Yes. Very good. Yeah. So the wave.
First question.
First question, but since the mode has changed, so the formula will be also changed. So the wave impedance for a T10 mode will have a formula of under root mu by E upon under root 1 minus FC by F square. Okay, so we know mu by E, right? Under root mu by E we know, and we will put FC, we know F, है ना? We have already found out FC from here. We have found out F. We'll put it in the formula and we will get it. The wave impedance. Right? Hmm. This you already know, right? ZTE will be 337.4 ohms. So option number A. Is there any doubt? Do you have any doubt here? No?
No, madam. No.
Okay, let's go ahead. Question number 5. So for the same information which is already given to us, now let's find out the attenuation constant due to the loss in the guide walls. Attenuation constant due to loss in the guide walls. Okay. So when a wave travels in a waveguide, there will be certain losses. Okay. Now these losses can be determined if we know the attenuation constant. So here it is asked what will be the attenuation constant. Attenuation constant basically means that there is a constant value if a guide is traveling in a waveguide, right? So there will be a constant value which will be telling us, which will be giving us the information about how the wave which is propagating is attenuating. Okay, the wave propagating, uh, how the attenuation is happening with the wave which is propagating in that medium. Okay, so now let's go to the question. Yeah, so the attenuation constant due to loss in the guide walls. Okay, so for that we have to first find out RS. Okay, for this formula. So can someone from you tell me if this has been taught to you or not in the NPTEL lectures? I hope there will be classes which, yeah, so you would have understood the formula there. You would have read the formula there. Okay, so for the attenuation constant is equals to RS into 1 plus 2b by a into fc by f squared divided by nb into under root of 1 minus fc by f squared. Okay, so before finding out the attenuation constant, we have to find out rs. So for rs, this is the formula for rs, which is pi under root of pi f mu c upon sigma c. So sigma c is given to us, right? Mu c is given to us. Everything is given. The frequency is given to us. We'll put it. We got 0.0501. Similarly, here B is given, A is given, eta is given, B again. So everything is given. We'll put all these values in there, and we will get the attenuation constant. Okay, and this is for 0.605. This is equals to 0.605 nepers per meter. Okay, is there any, do you have any doubt here? It's simple formula based question. So all the uh, uh, dimensions are given. A given, B given, sigma c is given to us, loss tangent is given to us, epsilon, mu r, everything is given to us. Loss tangent, that's tan delta. Yeah, so everything is given to us. We just have to put it in the formula and we will find out the attenuation constant. Do you have any doubt? No? Okay, let's go ahead. Question number 6. An air-filled rectangular waveguide of dimensions A is equals to 4 centimeter, B is equals to 2 centimeter transports energy in the dominant mode at rate 2 meter watts. Okay, at a rate of 2 meter watts in 2 milliwatts if the frequency of operation is 10 gigahertz. Okay, this is F. All right, the peak value of electric field in the waveguide is. Okay, so A is given, B is given, dominant mode at uh, rate of uh, uh, rate is given to us, frequency is given to us. So what is the first thing that is visible to you? And someone from tell me how to first thing that you can find out. See, the first thing is to find out the mode. What is will be the mode of the wave, right? First thing that we can find is what will be the mode, one thing. Another thing, what will be the dominant mode. Since all the formulas and everything depends on the what mode is there, we will be able to find out the solution after trying getting to know what will be the mode, right? So for that, one thing is given to us. A is equals to 4 and B is equals to 2 is given to us. So now can someone from you tell me how to find out dominant mode? Go ahead, try. Okay, so here A is bigger than B. Okay, so this means if A is bigger than B, this means that the dominant mode will be TE10 mode. Okay, now once you found out this thing that the dominant mode will be TE10 mode, then we can use all the formulas for TE10 and find out the field expressions and everything, right? So the dominant mode, since A is greater than B, will be TE10, and the field expressions corresponding to M is equals to N, M is equals to 1 and N is equals to 0 will be electric field in X direction will be 0, right? Electric field in Y direction will be minus J E0 sine pi X by A e to the power minus J beta Z. Do you have here any doubt here? This is formula based. Okay. So once you find out the mode is TE10, you will be able to say that EXX will be equals to 0 and EYX will be this expression, which is based on the formula, and E naught will be equals to omega mu A by pi H naught. Okay. Yeah. So for this we have to
Madam,
ha
madam, here a cutoff frequency formula is there, no, madam, above, madam, FC.
ha
Here we cannot substitute the root of mu, root of epsilon, or
hmm
only we are taken speed of light 3 into 10 power 8, no, madam.
hmm
3 into
yeah, go ahead. Hello.
2 A value we are substituting. What about epsilon value, madam?
What are you saying? I'm not getting. Can you
Uh,
repeat your question?
okay, okay, madam. Here cutoff frequency is there, no, madam. FC which is equal to
Ha.
u divided by 2A.
Hmm.
That already we have substituted speed of light 3 into 10 power 8,
Hmm.
and that the root of epsilon to r value here not substituting, no, madam. Here not taking, no. Any reason is there, madam?
Yes, yes. See, why it's not taken here is because here it is root epsilon r, but since the question here says that it's a air filled rectangular waveguide. Okay, so since it's air filled, right, epsilon r will be equals to 1. Okay, so air filled rectangular waveguide is given. If it was not air filled, some dielectric was there, then we have to put that here. But since it's not given, since it's air filled, epsilon r will be equals to 1, and we will be getting the cutoff frequency like this: 3 into 10 to the power 8 upon 2 into 4 into 10 to the power minus 2. Now, do you have any doubt?
Okay, madam. Thank you, madam.
Okay, all right. Then again, and eta for TE mode will be equals to this eta dash. Again, now eta dash will be equals to same eta because epsilon r here is 1. Okay, so then again this will be the formula. We'll put all the values. We know Fc, right? We know F, we'll put it, and we got eta. Okay, now yeah, one second. So uh, yeah, so now average power, if we have to find out E naught. Okay, here the peak value of electric field. So something like this can be taken as E, right? Something having a sine. All right, so some kind of sine curve is given. This will be the electric field, right? But the peak value will be equals to what? Peak value will be equals to E naught, okay, plus E naught minus E naught. So here we have to find out E naught. Okay, so here we said this, but we have to find out E naught. Okay, so to find out E naught, we know that E naught square is equals to power, average power, into 4 eta upon AB. Okay, now for finding out power average, we have to find now for finding out E naught, peak electric field, we have to find out power average. So for power average, we have to integrate this into EYS, okay, upon 2 eta dx dy, right? See, for power, average power, if we don't go into this integration, it's simple. E square upon 1 by 2 eta dx dy, right? And we have to integrate it. There will be two integrations, x and y. Any doubt here? Yeah, magnitude. So if magnitude is asked, then we will put EYS. Instead of EYS, we will put this in the formula and we will solve it. Simple integration. Okay, this, and then we will find out E naught square, which will be equals to P average upon 4 eta AB, and we will put all the values. We
Madam,
got it. Yeah, go ahead.
madam, what about the E power value, madam? E power minus J beta Z.
What?
That, madam, EY value is minus J E naught sine of pi x by A into E power minus J beta Z. But here we not substituting E power J beta. This value, madam.
This thing.
E power value. Here
Yeah,
only we are substituting sine.
yeah, because magnitude is asked to us now. Here magnitude is asked only.
Okay, okay, madam.
Okay.
E power square is sine square plus cos square is 1.
No, but
Okay, okay, madam.
this is for the phase. This
Okay,
value
okay.
is for phase. This is for the magnitude. So that's why we are
Okay,
not
thank you,
putting this.
madam.
Okay. So then we will put all the values in the formula and we got this value. 63.77 volts per meter. Option number A. Do you have any doubt here? It's formula based. The formula looks very heavy, but once you will be accustomed with these kind of equations, you will be able to solve these equations. All right, you won't right now for those who are in bachelor's, BTech second year or first year, no, not first year, second year, where electromagnetic theory is taught. So yeah, you might find these equations a bit heavy, but once you get accustomed with these equations, it won't be problem to you. Okay. Okay. Yeah, let's go ahead. It's simple sine square integration. You will do that and you will get e square ab upon 4 eta is equals to power average. This is also a formula. Okay, you put it and get it. Let's go to question number 7. An air filled 5 by 2 centimeter waveguide has again notice that the waveguide is filled with air. Okay, 5 by 2 centimeter has EZS is equals to 20 sine 40 pi x sine 50 pi y e to the power minus j beta z volts per meter at 15 gigahertz. Okay, so this is the operating frequency. This is E zeta ZS. It is filled with air and A and B is given to us. Okay, the propagating mode is asked to us. Can someone from you tell me the propagating mode? Try to solve it. I have already told you this thing, right? I have told you if A is greater
Madam,
than
here A greater than B is there.
yes.
A greater than B means TE.
Hmm. Yes.
TE only first two option any one, madam. But first two how to find out, madam? 1, 2 or 2, 1?
Okay. Let's go ahead and try to see that. Okay. No. So here,
No. Okay.
yeah, what is happening here is we need to see. So the propagating mode is propagating mode we have to see this thing also. For here, see, m by a is given to us, n by b. Okay, this is the 20 sine 40 pi x and sine 50 pi y. So how to identify it, how to identify which one will be the m term and which one will be the n by b term? So for that you have to check for the x. Okay, one second. X, so for x it will be m by a term. Okay, from here we can find out m by a, from here we can find out n by b. Now we know a and b, right? We know a and b, we don't know m and n. So we will we know m by a is equals to 40 from here. We know n by b is equals to 50 from here. So m will be 40 into a, that's 2. N will be 50 into b, that's 1. Okay, 2 and 1 we got. Now another thing, that was the trick. Here we use a trick, but if something is evidently given to you, then you have to go for that rather than the tricks. Okay, so here transverse magnetic wave contains a non-zero Ez, but Hz is equals to 0. Okay, for TM waves non-zero Ez is there, and here what is given to us, Ez is given which is non-zero, right? And Hz is equals to 0. Can some acha, it's already given here. I can, okay, can someone tell me if it's a transverse electric wave, then what will be the what will be the value of component of E in Z direction, and what will be the value of component of H in Z direction? If it's TE wave, the wave is in TE mode, then
Madam, the value is 0, madam.
yes.
E and H.
Hmm.
Direction of propagation only it is contain electromagnetic waves, not electric and magnetic field. So 0, madam. E z and H z.
No, Hz won't be 0 because for see again for transverse magnetic wave, Ez will be non-zero, but Hz will be 0. Okay, transverse magnetic wave. All right. For transverse electric wave, Ez will be 0 and Hz will be non-zero. Okay. So for this to be in for if this wave is given to us, so since Ez is given to us, it won't be TE mode, right? It can only be TM mode. And then we found out M and A. So M, this is M is equals to 2, N is equals to 1. So this is given to us. So option TM21. You have any doubt here?
Oh, how to find out a T or TM? That once again repeat, madam.
Okay.
Last line you told, no, how to find out T or TM mode.
Okay. So see, for TM mode, okay, Ez will be not equals to 0 and Hz will be equals to 0. Okay. For TE mode,
E z is 0, H z is not equal to 0.
yes.
Hmm.
Okay.
Okay, madam.
Now let's go ahead. In a dielectric slab waveguide, the cutoff frequency for even TE mode is, even TE mode is given to us. Cutoff frequencies are for a dielectric slab waveguide. So go ahead, try to tell me, try this question. Okay, so this is pretty simple uh, formula based question. For even TE mode, cutoff frequency is equals to n minus 1 by 2 divided by d into under root of mu d epsilon d minus mu naught epsilon naught. Okay, all right. Okay, let's go ahead to question number 9. If mu is the medium velocity, the relation between group velocity and phase velocity of the propagating wave is, okay, so I told you the difference between group velocity and phase velocity. So can someone from you tell me what I told you?
Madam, phase velocity is rate at which single waves, madam.
Wave
Group
propagation.
velocity means velocity at a group of waves.
Yes, good. Okay, so medium velocity is mu, right? Medium velocity is mu. The relation between group velocity and phase velocity is given by group velocity can be written as medium velocity square divided by phase velocity. Okay, medium velocity square. 1 second, I will write it. So medium velocity, the formula is medium velocity is equals to under root mu g mu p. Okay, shift all these things here and you will find out mu g is equals to mu square upon mu p. Okay, so medium velocity is equals to under root of mu g into mu p. This is the formula you would be knowing. So we can shift it and we will get this value. Okay, you have any doubt?
No, clear, madam, this one.
Okay, let's go ahead. Okay, question number 10. In a rectangular waveguide, TEMN and TMNN are called degenerate modes. If, okay, so So someone from you tell me what is degenerate modes. Okay, see, so those modes, okay, which have the same cutoff frequency but different field configurations, okay. So those since you know the formula for cutoff frequency, right? There are different formulas for cutoff frequency, okay. So sometimes uh, it's possible that for different modes the cutoff frequency is same. So those modes where cutoff frequency is different, but it has a different field configuration, those kind of modes are known as degenerate modes, okay. So to get degenerate modes, m and now n is should not be equals to 0, okay. If any of these will be equals to 0, then it's possible that the cutoff frequency won't be same, or the field configuration becomes same. The field configuration won't be same in most of the cases, but still, so cutoff frequency will change. So basically, those modes where cutoff frequency is same but has a these modes have different field configurations, those modes are known as degenerate modes. All right. So here, for those kind, to get those kind of degenerate modes, m should not be equals to 0 and n should not be equals to 0. So option D will be the correct answer. Okay. Do you have any doubt here? Okay. No doubt. No doubt, I think. Yeah. So you have any doubt?
Madam, this all parts related to microwave.
You.
Today, all 10 questions
Huh.
regarding microwave only, no? Microwave subject, no,
Yes.
madam.
Yes. Yes. But it's quite little.
Wave,
It's
yes, wave.
electromagnetic. Yeah. It goes into more electromagnetic. Please upload link on Google Sheet. Okay. Uh, which link are you talking about? Yeah, so what was I saying? Arun Raj. Yeah, so it is basic of microwave integrated circuits, basics, but yes, it's a little high level for electromagnetic theories. Yes. Can you, Tulsi Das, can you tell me what kind of link you are talking about? Do you want Google Meet link, or uh, I think he has left the session. Okay, all right. Okay, I'm not able to understand what kind of link he wants. Meet link. So meet link would be provided by NPTEL, right? Meeting link is provided by NPTEL, and for drive link I put it on my in the description of YouTube channel. So from there you can find out my drive link where these assignment solutions and everything will be given. And also I since I have recorded this whole video, I will put it on my channel as well. Okay. Chalo, all the best for assignment 11. I hope you score really good. Okay. Chalo, bye. All the best. Bye bye.